Today, I'm going to talk about geometry. That will be the coordinate geometry related to coordinate geometry. Now, I know most of you already studied coordinate geometry. Let's have a quick review about coordinate geometry. This is basically about two-dimensional. Okay, we're now going to talk about three-dimensional coordinate geometry. Two-dimensional coordinate geometry. You have a plane, and then you put two axes, okay, and they are, you can say they are perpendicular to each other, okay, because in the plane we have we can measure the length and the angle, so we just two lines cross to each other. Then you can define the angle and then look at it. Okay, so this is a coordinate line. Okay, we call it axis, y-axis. So now every point on the plane, you can use two numbers to describe because this is a coordinate line. Okay, so you have units. Okay, you can mark it 1, 2, 3, 4, and then it's even space. Okay, then every point you draw. Sorry, where's my file? Okay, sorry. So every point you can draw two lines, then you get the intersection point. Okay, and one is on x-axis, other one is y-axis. So the number, the coordinate of that point on the axis is, if we denote by a, the coordinate of the intersection point on the y-axis denoted by b, then you can use these two numbers to tell the location, the point in the plane. Okay, so now so that's about a coordinate system, and every point in the xy in the plane can be described by two numbers. Those two numbers are called the coordinates of the point. Okay. Then we can talk about we can describe the straight line. Okay, if you have a straight line in the plane with coordinate system, okay, then you can draw a triangle. Okay, write a triangle. It doesn't matter where you draw the right triangle. Let's you choose 2 points in on the line. Okay, then this, for example, this will has coordinates. I'm going to call it x1, y1. That one is x2, y2. Then the difference of this side is y2 minus y1. The difference is x2, x minus x2. Now, I assume that x2 is greater than x1, y2 is greater than y1 at this moment. I just want to show you a picture. So delta x could be negative, if x2 is less than x1. So then the ratio, this ratio, okay, we call slope. This is independent of the location of the points P1, P2, okay, is independent the locations of P1, P2 on the line. So this is this ratio will be the invariant of the line, and it's called the slope. Okay? M is called the slope of the line. Okay, using the slope of the line, then you can find a relationship of an arbitrary coordinates an arbitrary point because it's independent of the line. So you can calculate the slope in any slight different way. You can say you can use these 2 points. Okay, so y2 minus y1, x2 minus x1. So this should be the same number. Okay, therefore you find out and the relationship between the 2 coordinates of the point on the line. And that relationship is called, it's a linear equation, right? Linear, that means no x squared y there, y squared there. So this is called an equation for the line, okay? Okay, that's about the geometry of lines in the plane was a coordinate system. And conversely, if you're given a linear relationship between x and y, then x and y, those are the points of the line. So it determines a line. Okay. Now we do have a couple of the important facts about 2 lines. If 2 lines are parallel, so this line has a slope m1, a slope m2. So they are parallel, right? If and only if m1 equals m2. That's easy to see. Now, if they're perpendicular, if and only if m1 times m2 should be equal to -1. Okay? And this is not easy to see. Okay? I can show you a picture. Okay, just take a look at a line here passing through the origin. Okay, it has coordinates A and B, both are positive. Okay. So in this case, what is the slope? The slope of this line is going to be the difference, right? So this height is B, this side is A. So that's why it's B of A, right? Okay. When I locate this line, 90 degrees, so I get a line like that, right? So you get similar triangle, but how can I describe the coordinates of the corresponding point here? So this point is here, right? And the length becomes B, right? Horizontal length is B, but that will be negative. Then the vertical distance is A, so that's Y coordinate, positive. So that will be the coordinates of, just switch the order and put the negative sign in the first one. So how can I use this number to describe the slope? Slope, this is called M1, that's M2. Okay, it's going to be Y over X. All right, so that would be, you can say subtracted from 0, right? 0 minus 0, because this is a coordinate. It's the difference of Y coordinate over the difference of X coordinate. Okay, and here, yeah, we do the same. So they're perpendicular. You will see that M1 times M2. The first one is B over A. Second one is negative A over B. So that's why it's negative. Okay, so you understand why it's negative. All right, that's all about lines now. I can figure it out. All right. So our first question is, okay. All right. Okay. A line tangent to a circle at the point 2 and 5. The parallel line is tangent to the same circle at 8 and 13. What is a common slope? Now, what is the common slope of the two lines? Now, what are the slope of those two lines, basically? Okay. Those two lines, okay, let's see. Let me draw the picture, okay? So this is we don't know the circle, how it's located, right? Right. So we have 2 and 5. This is a point. Another point on the circle is 8 and 13. So let me draw the picture in slightly better way. There's a circle passing through those 2 points. That's just too many circles passing those 2 points. So let's draw one of them. Okay. So you have 2 lines. Now let me check what happens here. Okay. We know that the line passing through so it's not very clear. Let me check the oh, I see what is missing here. Okay. Let me redraw the picture. Yeah, there's additional information is missing. Otherwise, this problem is not solved. Okay, sorry for that. Yeah, so this is a circle actually. This is a line called L. It is passing through the center. Okay? So that's a picture. I did not put the picture here. Okay, so that's the picture, the information. This is the center. All right. So here, yeah, then it's clear. Okay. So this is those are 2 points opposite on the line. Okay. So this is 2 and 5. Yeah. The picture was not very clear in my opinion. Okay. So actually, so this is line L passing through the center of the circle. Okay, that's the first condition. Okay, and then this line. Okay, so you have 2 lines. That's why then you can parallel because they're perpendicular to the line segment from the center to the point. Okay, so first of all, you find out the slope. Okay, you find out the slope of the line. So slope of the line will be the difference of those 2 points, the difference of y coordinate. Okay, and the difference of the y coordinate. Yes. Just a second. Okay, the y coordinate, the difference of the y coordinate, and here's a -2, so the answer is 4/3. All right. So because those 2 lines are parallel, therefore they have the same slope. So that slope we call the m prime. Okay. So by definition, we know that because they're perpendicular to each other. So that's why it's going to be negative 1 over m, and that's just a 5 over 4. That's 4 over 3. 4 over 3, 3 over 4. That's it. Okay. So the picture was missing. That's why I'm confused about that problem. So that's it. All we need here are two properties. One property is if we have a tangent line to the circle, then this tangent line is perpendicular to the line from the tangent point to the center. Okay, and then first you figured out the slope of this line passing through the center of those 2 points. Then you can figure out not only the slope of those tangent lines, you can also find the equation of this tangent line. They are parallel, they have the same slope, okay? And the equation for the line, equation for the first line, it's y minus 5 equals, right? The slope is negative 4 over 4, negative 3 over 4, then x minus 2. Another line is y minus 13 equals negative 3 over 4, and x minus 8. The only difference between them after you simplify is the number. Let's look at the second one, okay? Let's look at the second one. So let's take a look at this equation. Okay, let's understand more about this, okay? So y minus 13, then you simplify, multiply this out, it will be 8, right? 3 over 4 times 8 will be 6, okay? Then you move 13 to the right-hand side. 13 plus 6 would be 19. Now, what does that mean? Okay, from here, what you can tell. So this is always a slope. Okay, if the coefficient y is 1, then this is a slope. This number, okay, we call it the y-intercept. The reason is when you let x to be 0, that means, okay, then the y value is be 19. Okay, the y value is going to be 19. So you can get additional point, and if here's 8, right, if this is 8 and 13, and slope is negative, okay, so that intersection point will be 19. You can also get an x-intercept, and then you have to solve the equation. You set y to be 0. Okay. Yeah, this is called the slope intercept force. Okay. So equation for a line will be in many different forms. That's why we say find any equation for the line. Because when you rewrite this equation, the constants, those constants will be changed. Okay, but they describe the same. They describe the same line. Okay. Our second problem, we're trying to find out the best way to find the problem, solve the problem. Okay. What is the y-intercept of the line? Okay. That is the perpendicular we call the bisect of the segment. joining those two points. Right? So basically, you have to find the equation for the bisector, then you get a y-intercept automatically, right? So let's draw the picture. Okay. So where are those 2 points? -3, -4 is somewhere here. 5, 10 is here. Okay. So you're going to draw the line, and you find the middle point and the perpendicular to it. Okay. So then you want to find out where it is, right? So what is the best way to solve this problem? Now, there are 2 different ways to solve the problem. One is, in order to determine this line, right, you have to find the middle point, right? Find the middle point, then you find the slope of the segment. Then you find the slope for the bisect, right? So that can be done, okay? But there are a couple ways to do. I'm going to show you. Okay. You can try first. Let me give me the answer, okay? If you can quickly solve the problem, then I show you 2 different ways to solve it. One method is called the natural method. So you find the middle point, right? The coordinates of the middle point formula is half of this, -3 plus 5. So it would be 2, that's 1, right? Y bar is going to be 10 minus 4, and the average value of the y coordinates, by 2. That would be 3. Okay. Then you also have to find the slope. Right, now those 2 lines perpendicular. The slope for the line segment, right? And it's going to be the difference of the y coordinates, 10 minus -4, 5 minus -3. So it's 14 and 8, right? 14 and 8, so simplifying, it's a 7/4. Then the slope for the bisector will be -4/7, negative reciprocal of the original slope. Then you can write an equation y minus y bar equals -4/7 x minus 1. Okay, that's the equation. So let's simplify it a little bit. Plus 4/7. Then I move 3 over to the right hand side. So it's a plus 3. Think 4/7 plus 3. 21, 25/7. That's it. Okay. So this is the y-intercept. Right? That's the first method. The second method, it's not natural, but for this special case, is, and here we have, I forgot the numbers, 5 and 10, right? And here is going to be negative, -3 and 4. Okay. Now, if you look at the line on this bisector, take an arbitrary point. You see the distance will be the same. So we use a distance formula. So we review the distance formula right now. Right? The distance of the first one between, right, is going to square root of the difference of the y coordinates and the difference of the x coordinates. Another one, the distance, okay, is going to be y minus -4, so +4. And x minus -3 is +3. So that must be equal. Well, it looks that looks complicated, right? But it's okay. We square it. Y minus 10 squared, x minus 5 squared, right? And here y plus 4 squared and x minus plus 3 squared. So when you square it, it's minus 20y, and this is 100. Here's x squared minus 10, x plus 25, and on the right-hand side, y squared plus 8y plus 16, and x squared plus 6x plus 9. Great. If you look at both sides, y squared is gone, x squared is gone. So it's not going to be the linear quadratic equation. And the 9 and the 16, it should be 25. Even that is gone. So let's simplify here, right? So you have negative 20y plus 100 minus 10x. Okay. The right-hand side is 8y plus 6x. So we move all the terms to the right-hand side. So I get 28y plus 16x. And I can still keep 100 on the left-hand side, okay? Which now is view on the right-hand side. Okay. So my answer will be y equals, I still keep a 16 on the right, 16 over 28x plus 100 over 28, okay? And well, you simplify, okay? You can simplify. 100 divided by 28, it's a factor of 4 there. So here's 4 over 7, and that will be 25 over 7. So yeah, now you have two different ones. I think the first method is more natural than the second method. Okay. I'm trying to give you another problem. Also, I have two different methods. Okay. Okay. So we know that. Okay. Okay. If the following points, okay, 1 and 7, 13, right, and the 5 and the 19, and the 28, T are on the same line. What is the value of T? What is the value of T? First of all, you don't need 3 points. You have to check whether those 3 points are on the same line, because those are very specific. Right? Yeah, anyone has answers to this problem? You are given more information than you need. All right, so let's work out. First of all, you check whether those are, when you're given additional information, you have to question, whether those are on the same point. So let's take a look at the slope determined by those 2 points, okay? 2 pairs of points. One is a slope, 13 minus 7, 3 minus 1, which is 6 over 2 to 3. Here's slope 2. 19 minus 13, 5 minus 3. That will be 6 over 2. So that's 3. So that's why if they have the same slope, and then they must be on the same line. The reason is if this is a 13, 3 and 13, right? You have another slope, right? This is a slope of 2, then other point is slope of 2. Slope of 3. So those have the same slope and passing through the same point, they must be on the same line. So you don't need so many points actually. Remember, 2 points is enough to determine a straight line. Now since 28 and t is another point, right? So you can also calculate the slope using the point in the middle point, right? T minus 13, 28 minus 3, right? So that should be equal to 3. That's all you need, okay? So t minus 13 equals 3 times 28 minus 3 with 25, it's 75. So t is going to be 75 plus 13 will be 88. Okay. Okay, that's about the slope. Right. Now, another way to solve the problem is you just find the equation of, you don't use a slope, just find the equation of the strict line. Right? You find the equation of the strict line, what you can get, okay? So use the end of the point slope, right? So y minus 13 equals 3 and x minus 3, right? Right? Use the middle point. And you know the slope is 3. So y minus 3 minus 13 equals 3x. Oops. 3x minus 9. Right? So y equals 3x. Does not allow me to write down the screen. 3x is 13 minus 9 is plus 4. Okay, so that is the equation, right? Now, once you have the equation, you know that the y, t is the, right? So you have the point 28 and t is on the line. So just then you plug the 28 for x, t for y, then you solve for y. 3 times 28 plus 4. So you end up with 88 again. Okay. So you don't use another slope. Okay. Now here, the problem is a little bit tricky. Okay. We know that, okay, if 2 negative 5, p negative 14, p plus 2 negative 17, 13, and q are on the same line. Okay, find the value p and q. Okay, I want you to try it now. Okay. So you have 4 points on the same line, but they're not arbitrary. Okay, partial of the information is already determined. Since there's an online same line, it should determine the value of P and Q. Okay, so please do this. All right. So Grant says Q, also he found a Q. P is 8, is correct. Are you sure Q is 26 over 3? I think once you get P, then it's easy to get Q. Okay. Good job. Yeah, great. So you have to carefully choose a 2-point to determine the slope. Okay. So if you choose those 2 points, then you find out. Yeah, let's take a look at the slope of line. Okay. So those 2 points, the difference is that coordinates. For example, I say -14 minus -17, and P minus P plus 2. So actually the slope can be determined. Right? So that will be 17 minus 14, right? It's here's -2. The slope will be the slope will be -3 over 2. But on the other hand, then you can use these 2 pairs of points, right? And that will be, -5 minus -14, and 2 minus P. Okay, so that will be that 14 minus 5, right? 14 minus 5 will be 9, okay? And the 2 minus P. So from here, you determine the value of P, right? And, right? So 9, 2 minus P equals -3 over 2. Let's do the computation quickly. So 18 plus product equals 3P minus 6. Okay. So P is going to be 8. So 24 divided by 3, so it's 8. So that is value P. Then you use this point 13 and the Q. Okay, and with any of these points. Okay, let's use a -3 and 5, 2 and a -3. Okay, so the slope, right, is Q minus 5, and 13, Q minus -5, so Q plus 5, and 13 minus 2. Okay, so that's it. It's Q plus 5, and that is 11. Okay, okay, let's double check. right? Q minus, so, and 13 minus 2. Okay. Okay, so right, so Q plus 5 over 11 is negative 3 over 2, and then Q equals negative 3 over 2 times 11 and minus 5. Okay, after simplifying, it will be negative 43 over 2. All right, now our next problem is to determine which point will be above the line. Okay, okay, among, how to determine that? Among the point, right? I have a list of the points. How do we quickly check that? Among those points, 20 and 50, which are above the line, okay? The line is y equals 2x plus 7. Now let's understand the equation first. Okay. Let's understand the equation first. So y equals 2x plus 7. This can be written in the form y minus 2x equals 7. Okay. So this is a quantity, okay, never be changed. Okay, what happens if I look at this in general? Okay, the only difference, so when I change the value of the k, and here's a 7, okay, so this is a line, okay, and y minus 2x equals 7, right? At the slope of 2, y coordinates 7. So when I change the value of the k, I only change the, I get a parallel lines, but then I find out, so k is just the y-intercept. If you notice that, then a point on the, if a point is above the line, above this red line, right? What you can do? Suppose you have a point x and y, then this will be on one of the lines, right? And the corresponding value of k must be greater than 7 if it is above the, of the line, okay? Right? So all I have to do is just to check the value of y minus 2x, okay? So we have how many points do we have, right? We have 5, right? So you check the value of y minus 2x, okay? Then if we get a k which is greater than 7, then this is above the line, which is if this here, x, so right, y minus 2x equals k is less than 7. Here's y minus 2x greater than 7 equals k greater than 7. So if you want to determine which one is above the line, and you just needed to look at the value. Okay, and you will see that, let's see, 10 minus 2 times 3, which is less than 7, right? 20 minus 2 times 6, which is greater than 7. Okay, it's 9, right? And 35 minus 2 times 12, okay, which is greater than 7. And then 40 minus 2 times 18, which is less than 7, right? Because 36, yes. And 50 minus 2 times 20, which is greater than 7. So you have, which one is greater than 7? This is greater than 7. That is greater than 7. And the last one greater than 7. Okay, those are the points above the line. Okay, so what we learned here what we learned here is the line is called the level curve of the function. Okay, so the line, yeah, those lines are called the level curves of the function. Of the function, this is a function has a two variable, y minus 2x. Okay. When you change the value, then you get family of lines, but they're parallel. All right, let's take a look at the next problem. I'm going to draw the picture here. So this is in the XY coordinate system, and I have a picture here. So I have a point 0, 0, and that is a point 8, 0, and 11 and 4, and here 0 and 4. So this is a trapezoid. Okay. I want to find out clearly, like this line, if I draw this line on this diagonal, then the triangle below the diagonal has less area than the triangle above the diagonal, right? So I have to move to here a little bit, okay? And this is gonna be x and 4. So I needed to find out, I have to find out, yeah, what I have to find out. Okay, I want to find out the question one, find the x such that the two region has an equal area. Okay. Second question is find another x such that the two region has equal parameters. All right, so just why the diagonal does not give you the equal parameter. The diagonal, I think for the diagonal, the parameter, I don't know, the one below that maybe have a short the parameter, okay? So then you have to move the point to the left a little bit. Okay, let's look at this, right? This side is 8. This side, use a Pythagorean theory. 11 minus 8 is 3, 3, and okay, this is 5. So 5 plus 8 is going to be 13. The other one here, this is 4. It's 11, right? So that's why it's longer, 4 and 11. Right, 4 and 11 is greater than 8 and 5, 8 plus 5. So that's why the diagonal does not give you the two regions of an equal parameter and the equal area. So you have to move the point a little bit. So you have to determine the value of x such that they have the equal area and another x have an equal parameter. Okay. Anyone has answers for the first one and for the second one? So 19 over 2 is put them for same equal area, right? But anyone else? Erica, okay. She also got an answer. Great, great. So find the area. What is the trick? So you're going to divide the region into two equal areas. So you can determine what is that area, because the area of the trapezoid, okay, area of the trapezoid right, is going to be average value of the top one, right? The bottom is 8, the top one is 11, and the height is going to be 4. So basically, this is 19 times 2, right? 19 times 2. 38. Okay, so that is the area of trapezoid. Then you divide by 2, and the area, half of the area is going to be, 19. Then you just check the area of the triangle. The area of the triangle, half, the base is 4, the height is x. So that's why it's going to be half of the area of the trapezoid. So it's 19. So that's why x is going to be 19 over 2. Okay? That's the first. Second, to find the parameter, there's a common side, which is called d. You don't need to know that, right? So the parameter of the triangle is 4 plus x plus d. And the parameter of the one below that, right? You have 4 sides. So that will be 11 minus x, right? Plus 5 plus 8 plus d. Okay, so that's equal. So dd will be canceled out. So 4 plus x equals, right? So 13 plus 11. So it's 24 minus x. Okay, it's 2x equals 20, x equals 10. Great. So everybody got the right answer. Yeah, good job. But the trick is, you have to figure it out the area of the trapezoid. Right? For the second one, you should know that there's a shared side. Okay. Let's finish the last problem. Okay. So here's a question. Now this is a topic about fraction. Okay, so 0.23 is refracted about the x-axis to the point, to P, another point. Then P is refracted about the line y equals x to q. Okay. Find the coordinates of q. All right, so refraction, let's talk about refraction. Refraction about the x-axis. So this is a point, right? Has coordinates A and B. And then you have to draw a perpendicular to the x-axis and have the same distance. So the first coordinate is still A. The second coordinate will be B, negative B. That's easy to understand. Now, how to determine this line, right? Y equals X. Suppose you have a point here, A and B. Okay, how to get as a point? This is a refracted about the line y equals x. So you have to draw the line perpendicular to that and extend it, then have it for the same equal distance. So that is the difficult part, probably. All right. Yeah. How to find the other point. Okay. Okay. Yes. So let's do the problem step by step. Okay. The first point has coordinates 2 and 3. Then this point was coordinates 2 and the -3. Okay. So let's go here and the 2 and the -3, 1 and 2, 1, 2, 3, 2 and the -3. Okay. So actually I want to get some point here. Okay. How do you quickly find the point Q? That's a Q. Okay. The idea is, anyone has an idea? No, not yet, right? So let's go to the general form again. Look at this picture, right? So the say by the symmetry, right? This two triangle will be similar. That's that's okay. Those two triangle congruent. So if this side is A, this side is B, what you can get? And this side would be A, that side would be B. So you all have to do is just switch the order, B and A. Okay. So those 2 points are always, first of all, you double check, right? The middle point is half of that. So this is a middle point, half of A plus B, half of A plus B. This is indeed a point on the line y equals x, because the first coordinate equals the second coordinate, right? Double check, right? Then, and you can calculate the distance. This distance equals that distance, right? Because the middle point is on this line, okay? So if you know this, then the answer is very simple, and that point will be just switch the order. Okay, that's it. So -3/2. Yeah, we should know about we should know the refractions about the line y equals x, and also the refraction about the x-axis and y-axis. Okay, I haven't discussed anything about the circle equation for circles. Sometimes we do need to know about that equation for circles. That is probably 9th grade math. Okay. About SAT math, do you have any chance to take it? So you can see how, I think as long as you able to solve most of the problems on Mathcounts, okay, and you can try and take the SAT test in mathematics, you should get almost the perfect scores. Okay, if you have a chance, then you can try this. Okay, maybe I can send you a test to your parents, so later on you can test it by yourself to see how many problems you can solve. Okay. Let's stop here.